So we're looking at a word problem that is going to use the square root method. So what I would suggest is pause the video, take a moment and read the word problem, figure out what you're being asked to do, and then hit play again and come back, and I'm going to go through it with you what you should be doing in this case. But take a moment and read it and process what the problem's about. Okay, so I've highlighted some key information in here, and they're telling us what the variables represent, right? T is equal to time, h is equal to height, and I do see those represented in my problem. Right, and they're asking me down here to approximate the time it will take for the object to reach a height of 200 feet. So what they're telling me, this last blue highlighted height of 200 feet is, for this equation, I know h represents height, and they're giving me a height, which means I can go right here, and I can plug in 200. So I'm going to rewrite this equation that they gave me, but now I know the height. So I'm going to say negative 16t squared plus 500. And this is an equation that is a classic example of when do you use the square root method. There's no t to the first, there's only one variable in the problem, and so I'm going to solve this by isolating t squared. So I'm going to say minus 500 on both sides. Okay. We're starting to get t squared alone, so it's going to look like now negative 16t squared is equal to negative 300. Okay. And now I need to go and divide both sides by negative 16. Divide by negative 16. Right? And again, if you need to use a calculator for something like this, go right ahead. Negative 300 divided by negative 16. Right? You're going to get a decimal. This is real life situation, 18.75. So we're going to say this is 18.75 is equal to, remember this canceled, so I just left with t squared. And I need a square root. Again, asking you to do that in your head, I wouldn't do that in my head, so I'm not going to ask you to do it. Right? The square root of 18.75. Okay. Close that up, and we find out it's about 4.33. So after I do this square rooting, I'm going to say that the time is equal to, t is equal to 4.33. Okay, and notice I'm not including the negative version of this. We're talking about a real life situation, and that is time. So there's no such thing as negative time, so I'm only counting the positive version. Okay, so it's a very straightforward solve problem. You just have to know how to apply the word problem aspects, set up the equation that you want to solve, and then use the square root method to solve it. Okay, so here's one more type of problem that I want you to see. And if you think back to way back at the beginning of the year, we learned something about the absolute value functions. And the idea of an absolute value function is, let's isolate the absolute value bars, right? Get all of the stuff that's on the outside away, right? And I'm not going to complete this problem, but if we divide both sides by 2, we'd say now we're to the step where the only thing on the left-hand side is the absolute value bars. Okay, so when we get this square root method problem, you might see some problems that are very similar to that. If you take a look at this example here, it's the same basic idea. The left-hand side, instead of being absolute value bars, is now a parentheses squared. Right, so it's just a different operation on this stuff, but it's going to be the same thing. So I'm going to say in this problem, I can square root this entire big expression. So now here's the trickier part about this. I did this because the squared and the square root will cancel and just leave me with x minus 2. Okay? The square root of 25 we know is 5. Okay? However, there's another square root of 25. I can also say the square root of 25 is negative 5. So I'm going to come over here and write a whole separate equation to represent negative 5 as a possible answer as well. Okay? So you can solve each of these now. Okay? This is something that's solvable. Okay? So I can say x is equal to 7. Okay. And in this one, when I add 2 and add 2, x is equal to negative 3. So I got my 2 answers. We've been getting 2 answers on all of these quadratics, but we're using a slightly different process because there's a squared with stuff inside of it. Okay. So here's a second example for you, and this one has to do with the same idea. I'm going to try to isolate the squared, but I have this 13 on the outside, so my first job is, let's get rid of that, right? And then basically go through the same process after that. So I've isolated my squared. It's the only thing on the left. That equals 1. I'm going to square root both sides. Okay, and I'm going to say, well, either x plus 5 is equal to 1, well, the square root of 1 is 1, or x plus 5 is equal to negative 1. And again, you can solve each of these. Out of the left-hand one, you're going to get a negative 4. And out of the right-hand one, you're going to get a negative 6. So again, I got my 2 answers. Negative 6. Okay, so it's the same basic idea. You're just going to have, as we did with the absolute values, you're just going to have to do it with the squares and square roots now, right? So one more example, right? So we have to get rid of the 11 that's on the outside and the 2 that's on the outside. Always undo your addition and subtraction first, right? So we're going to find out that 2 parentheses x minus 10 squared is equal to 8. Okay, I have to get rid of 2 times, which is done by dividing. I'm going to find out that x minus 10 squared is equal to 4. And now I can square root. So I'm going to say the square root gets rid of the squared, and that means I also have to take the square root of 4. So I'm going to find out that x minus 10 is equal to 2, or x minus 10 is equal to negative 2. And again, these are both solvable. I'm going to get a 12, and over here, I'm going to get an 8.